What's up, Professor? I'm going to be doing my two questions for week 4A. We're going to start off with question 5 here. At an amusement park, there was a ride in which cylindrically shaped chambers spin around a central axis. People sit in people sit in seats facing the axis, their backs against the outer wall. At one instant, the outer wall moves at a speed of 3.67 meters per second, and a 67.3 kilogram person feels a 456 Newton force pressing against his back. What is the radius of the chamber? That's the question that we're going to be doing. So let's just go ahead and draw it out first. That's what we like to do here. Let's do pencil here. We're going to draw it out by doing a little circle, and my little guy is going to be right here, right? Give me his little seat. Boosh, 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 boosh. He's going to have his weight coming down here in kilograms. He's going to have his static friction up here, and then this is going to be the normal force, which is the centripetal force. Centripetal force. And his velocity is going to be. Oops, that's okay. His velocity is going to be 3.67, I believe. 3.67 meters per second. And velocity is. The SI units for velocity is going to be meters over seconds. And then the weight is going to be 67.3 kilograms, and the SI units for the weight is going to be kilograms in this situation. And then we have our force, centripetal force, which is going to be the normal force exerted here, which is 456 newtons, the SI units being newtons. And since we're going to be using the centripetal force, we're going to be using the equation F equals mv squared over r, which is the radius. We're looking for radius. So we're going to switch these two here, right? This is the original equation. We're going to swap these two so that we can actually, solve for r in this situation. So mv squared over f of c. And, we have all the numbers, so let's just plug in here. So r is going to equal 67.3 times 3.67 to the second over 456 newtons. And, when we do the calculations, r is going to come out to 1.99 meters, SI units being meters. And this is the radius of the chamber that we saw here. So pretty cool question. Like it. It's a little quick, a little remind me of it, but it's nice. I do like it. And then I think question 12. This one was pretty had to understand it more. You feel me? But same kind of like area. So we're gonna have a circle, and it's gonna be moving clockwise with the string holding up the cylinder. Obviously, it's going this way. And it's going to be going clockwise, like I said. And it's asking here, a small cylinder rests on a circular turntable that is rotating clockwise at a constant speed. Make sure we realize that it's constant. Which set of vectors gives the direction of the velocity v and acceleration a of the cylinder and the net force F that acts on it? So right off the rip, we can see that v are all the same. Why is the velocity all the same? Because velocity is always going to be tangent to the circle. So by saying that the velocity is going to be tangent to the circle, it's going to be tangent to just where the object is moving. So since this is turning clockwise, then the velocity is going to be this way. Right? So this is going to be the velocity. And then we have acceleration and force. Well, there is only centripetal acceleration, and centripetal acceleration always points towards the center from wherever you're at. You could be over here, it's going to point to the center. You could be over here, it's going to point to the center. You could be over here, it's going to point to the center. Either way, it's going to point this way. The velocity isn't in the middle. Scratch that. It's going to be out here. So velocity, it's going to be the right. And then the net force is also the exact same way that the centripetal acceleration points. That's just a fact. It's going to point this way. This is going to be the force that's asking about. Yep. And it's going to be the same for all of them, pointing towards the center. And we look here and we picked 4. So velocity is going to be right because that's the way the rotation of the turntable is happening. Acceleration is going to be down because centripetal acceleration is going to be pointing towards the center. And the force follows the acceleration. And those are my 2 questions for week 4A. Yep, I'll see you next week.